So now we have the next speaker is from Europe, Alex Stancu. He is a senior systems engineer or an expert with Linux Foundation Aether project. And so he'll be talking about what's happening, how do you make use of some of the open source out there, and apply that for deployment. Alex, you're online?
Yes, can you hear me?
Okay. Yes, please go ahead. You have about 20 minutes. Folks, we are running a little late, so we'll take a short break after this. Coffee break, coffee is outside. Health break, then we come back. And then we have Mary Sylvie from US Ignite NSF talking about power test, but later. Go ahead, Alex, thanks.
Okay, so can you see my screen?
Yeah, we can see. We can see the screen.
Okay, thank you so much. Okay, so hey everybody, this is Alex Stancu, and I'm a senior systems engineer. I also serve as a PTL, a project technical lead for the simulations project inside the Oran software community in Linux Foundation. And I would like to talk a little bit about the open source software, as a catalyst for the innovation in this Oran ecosystem. I will take less than 20 minutes. I know we are delayed and everybody waits for that coffee break, so I'll be fast. I wanted to touch a little bit about the Open Run, but I think the audience already knows about it. It's here just for completeness. I will not spend time on it. Then what is the role of open source software in telecommunications, historically speaking, and nowadays, what are the projects in this space? And then how innovation happens through open source in this Open Run context. And then to give some case studies, examples, and ongoing efforts from our LF Aether and also from the Oran software community perspective. Then I listed a little bit the benefits and challenges at this, and we will conclude on the presentation. So I will skip this. Everybody knows what is Open Run. It's the disaggregated run with the open and interoperable interfaces. Let's get more to it. So what is the role of open source in open source software in telecommunications? So it has a long history in telecommunication, of course, starting with Linux as the foundation for many telecom systems due to its robustness, flexibility, and security features. So Linux became the de facto operating system for many telecom servers and network functions due to its stability and wide range of supported hardware. And then afterwards, I will give some examples of other open source projects which are relevant in this space. So then we can put OpenStack on top, which provides the infrastructure for NFV and supports the deployment of virtualized network functions. And of course, on top of that, we can add Kubernetes, which it's an orchestrator, so manages the containerized network function, and it supports all the microservices architecture in the telecom networks. But then on top of that, for the Open Run, what do we have? So we can have in the run space, I listed here a few projects. So it's the SD-RAN project from Aether. SD-RAN, it's a near real-time RIC implementation, which is compliant to the E2 interface of the Oran specifications. We have also, of course, the Oran software community, which is the community partnering with the Oran Alliance and Linux Foundation to support the software development for an Open Run solution that it's available to everyone. And it's very good that it also provides rapid feedback to the Oran Alliance working groups about the interfaces and architecture and how it can be really used in practice. We have also Open Air interface and SRS Run, which these are open software for building 4G or 5G software radio suites. Also, Open Air interface has a core component, but I didn't list that as well. And of course, we need also the core component of the network. I listed here only SD core. There are much more 5G open source cores out there. But SD core, it's also part of the Aether project. So it's a cloud native mobile core, both 4G and 5G. And On top of that, for example, comes the Aether project, which this is a leading open source private 5G platform. So it can make use of the SD core and other RAN components. Even it can be deployed with commercially available 4G or 5G small cells. We have also a Smart 5G, which is an initiative also from the Aether project, which stands for Sustainable Mobile and RAN Transformation. So this is basically a use case of the underlying open source project. So it is a collaborative effort to develop and enable ML-driven energy savings solutions. And it does that through a series of POCs that demonstrate progressively advanced energy savings technique for Open RAN, but also for, let's say, traditional RAN architectures. I would list here also ONAP because it's an important framework that can be used as SMO, a service management and orchestrator platform for the RAN functions. And also on top of that comes somehow overarching this ORAN OSFG that also Chilin talked about. So it's the open source focus group, which is a focus group under the ORAN TSC, dealing with open source related issues for the ORAN Alliance, and it handles also coordination with open source communities, in the end, also as a goal, providing an open source reference architecture for end-to-end deployment. And what is the impact that all of these open source software projects bring on innovation? We have, of course, accelerated development cycles because open source models enable faster development and deployment of new technologies by leveraging the collective efforts of a global community of developers. So this means a faster time to market for new features and capabilities. But also we have a community-driven innovation because now innovation is no longer confined to the R&D departments of large corporations, because anybody can contribute. You take the code and you can come up with new ideas. Also, vendor independence is somehow assured because open source software reduces the dependency on specific vendors, giving the operators, telecom operators, more control over their networks. They can now mix and match components and customize the software and implement new features without being tied to a specific provider. It also brings more security and quality because it's open source, the code is transparent, it can be continuously peer reviewed. This can lead to more secure and a higher quality software. But also the adoption is somehow slow at first because the code is not production ready, and it takes a while for it to become usable in production. But once it gains momentum, the adoption grows exponentially. So that was also the case for Linux, right? It took some years before it was really used, and now it's everywhere. And I want to talk a little bit about a case study. So where can we use this open source project? And I have here an example for energy savings and traffic steering. It's a simple use case, very simple, with 3 cells with significant coverage. One of them is a capacity cell. The 2 others are coverage cells. Of course, when there is no traffic, we could shut down the capacity cell in order to save some energy. And how can we do that? We could have an energy savings RAP, which can do predictions based on AI/ML models, and also a traffic steering XApp that would work hand in hand with the energy savings RAP in order to drain the cells before shutting them down, such that users are not affected. So keeping this use case in mind, There were some demos happening with open source software. One was in Fuse in Madrid last October, where we used the SMO and non-real-time rig frameworks from the Oran software community, the near real-time rig from the SD-RAN project, and a RAN simulator it was a combination from SD-RAN, RAN sim, and also the Oran software community simulations project. And Remedo Labs has developed here one RAP for energy savings and one XAP, doing intelligent cell on-off, and also the traffic steering. And Tieto here was the company which provided system integration. So with the help of these open source components, we were able to do such a demo. And then this demo evolved. Yeah. So in March 2024 in RIG Forum, we had the energy savings RAP now coming from Intel, which was a powerful RAP using an AI/ML model, which was trained on real network data, which came from Telecom Italia. It's an open source data set. Again, the open source components from the Oran software community, from the SD-RAN project. We replaced the simulator with a commercial grade simulator from Viavi. Everything happened in the I14Y lab, which is also an OTIC in Europe. And the novelty here was that we could demonstrate interoperability between RAP and XAP from different vendors. And going forward, we want to expand those demos. For example, there is an ongoing effort in I14Y lab. Again, we want to use the open source SMO and non-real-time rig frameworks. But the idea is to try to do a traffic steering RAP this time, so not an XAP, but an RAP. This will trigger, of course, some research that we need to do, how to do the traffic steering over the O1 interface. But again, this is how open source can trigger innovation, right, in this space. And the goal of the demo is to advance to a field trial eventually. Another demo that is an ongoing effort under preparation, it's in Powder Lab in University of Utah. Again, we have deployed the Oran software community SMO and non-real-time rig frameworks. But here we would like to demonstrate commercial RAPs on top of that open source stack, and to put that on top of a commercial simulator. Again, just to demonstrate that RAPs can work also and with the open interfaces, can work with the open source stack. And eventually the goal is to replace the RAN sim with real hardware from the Powder outdoor testbed. Another ongoing effort, it's this NTIA R&D grant called 5G Energy Efficiency, Metrics Models and System Tests. So this is a project in collaboration with WinLab, Rutgers University. The goal is to research and develop and validate accurate test methodology. So how to measure efficiently the energy efficiently of 5G network components. And again, for all the experiments in WinLab, we are using open source components from the Oran software community, from OEI, from SRS Run, in conjunction with commercial RUs. There is also an ongoing effort about rig evaluation. So this is led by the Aether and Oran software community projects. The purpose here is to assess the state of the open source near real-time rig frameworks which are out there. To name a few, we have from the Oran software community, from the SD-RAN project, also OpenAir interface has the FlexRig. And these are steps that we are taking towards the harmonization in the different communities. And the study itself is being conducted by Remedo Labs because of their extensive experience with writing XAPs and all kinds of open source and also commercial near real-time rig implementations.
Alex, you can wrap it up in next 5 minutes. Thanks.
Yes. Mm-hmm. And there is also an ongoing effort, as Tracy was mentioning earlier in her presentation, in this Indigo project, funded by NSF. So she was talking about the AA planner and the multi-operator SMO. But if we go a little down in the architecture, the single operator SMO comes from the Oran software community, this open source project, and also the simulated run comes from the Oran software community simulator project, currently with a focus on the O1 and open fronthaul and plane interfaces. So there are a lot of activities out there for this open source project. I think we can skip all the benefits and challenges of this open source software in Open RAN. I listed them here for completeness, but yeah, what I wanted to show was really how the open source projects are being used to advance this Open RAN. So to wrap it up, there is a change in the telecom landscape with this Open RAN, and open source software is a big part of it. And again, we need to, so everybody, the telecom operators, the vendors, the regulators, and the developers need to keep collaborating and to continue the investment in these areas, because these are the key to realizing the full potential of Open RAN. So that's it. I wanted to finish a little earlier.
Thank you, Alex. So I know there was a talk about MEC and RAN integration before. So this is a good way to get some open source and try to get those. I don't know if anybody is using Aether. We have talked to Larry Peterson at some point. He actually gave a talk at an Institute of SA Autonomy. Any question, folks? Maybe we can take one question from the audience. A question on the back.
Do you see this as being a way to cut down on some of the costs in area cost? Do you see this as being a way to cut down on some of both the energy costs and the development costs for places that don't have so many resources?
Well, yes, so for sure, energy costs. Yeah, this is the purpose of all these energy savings ARAP studies, and with the other costs, it depends, I would say, because again, many people think, hey, it's open source, it's free to use and so on, but somebody needs to invest in that open source, until you can make it self-sustain. I think there an investment is needed in order for the software to stay up to date and security to be okay and so on. So I think that's a trade-off which can be done for the, let's say, human costs. But yeah, for the energy, definitely it can be done.
I'm involved in some DC microgrids in some rural areas outside of the US and outside of Europe, and there's not much energy. You know, yes, you can put in many solar panels in, put in banks of batteries, but at the end of the day, you want to save as much energy as you can with everything you're doing.
I agree. Yeah. Yeah, but it also depends on operator needs, right? So we had a talk with an operator in the Middle East, and they said, we don't care about energy savings. We have enough energy here.
I think that is an interesting area also, energy optimization. I mean, within IEEE, you have energy efficiency working group. And Chilean also talked about green ICT and a lot of other things going on. NextG Alliance, they have a sustainability working group. So I think we should keep in mind some folks can do some experimental work there. So with that, let's take a break. Let's first thanks the speaker. Alex, thank you very much.
Thank you also.